These are solutions to Calc 1 final exam. Number 1, f of x minus f of a over x minus a is 1 over x squared minus 1 over a squared divided by x minus a. Multiply numerator and denominator by a squared x squared, which is the common denominator here. Gives me a squared minus x squared over a squared x minus a. The numerator factors into a plus x, a minus x, and a minus x over x minus a comes out to be -1. So I can rewrite the final answer as negative a plus x all over a squared x squared. Number 2, this is y equals x squared. This is y equals negative x squared. Should put a negative there. And then negative x minus 2 squared minus 3, I take this graph and move it 2 to the right and 3 down, so the vertex becomes 2, -3. Number 3, y, call the function f of x, y equals 2x plus 3 over 3x minus 2. Switch x and y. So x equals 2y plus 3 over 3y minus 2. Multiply both sides by 3y minus 2. Distribute here, that gives me 3xy minus 2x. This cancels out, so I get 2y plus 3. Put the y's together, so subtract 2y and add 2x. 3x minus y minus 2y equals 2x plus 3. Factor out the y. Y parentheses 3x minus 2 equals 2x plus 3. Divide both sides by 3x minus 2. So y equals f inverse of x is 2x plus 3 over 3x minus 2. Number 4, multiply numerator and denominator by 3 plus radical x, the conjugate of the denominator. So I have limit as x approaches 9 of 9 minus x times 3 plus radical x. This is a minus b, a plus b. That's going to be 9 minus x. Very conveniently, it's the same as the 9 minus x here. So these cancel out. Limit as x approaches 9 of 3 plus radical x. Now directly substitute, put 9 here, 3 plus radical 9, 3 plus 3, which is 6. Number 5, given epsilon greater than 0, find a delta greater than 0 such that 0 less than absolute value of x minus 3 is less than delta, implies the absolute value of the function minus the limit, 6x minus 18, is less than epsilon. So scratch paper, absolute value of 6x minus 18 less than epsilon, factor a 6 out, divide by 6. So absolute value, the arrow means implies, absolute value of x minus 3, which matches the left-hand side, is less than epsilon over 6. So let delta equal epsilon over 6. So started the proof. 0 less than absolute value of x minus 3 is less than delta. Means you can drop to 0 now. Absolute value of x minus 3 is less than delta is epsilon over 6. Multiply both sides by 6 and distribute back in. So absolute value of 6x minus 18 is less than epsilon. Number 6, the derivative is limit h approaches 0 of f of x plus h squared, minus f of x squared all over h. Limit h approaches 0, x squared plus 2xh plus h squared minus x squared all over h. X squared cancels out. Factor out an h from each of these. Limit h approaches 0 of 2x plus h is canceled out. And here, if I plug in 0, I get 2x. 27, a little bit clumsy. So quotient root, bottom times the derivative of the top, 2x, minus the top times the derivative of the bottom, -3, all over 1 minus 3x quantity squared. You are going to have to simplify the first derivative to make it look nicer. So that's going to be 2x minus 6x squared plus 3x squared. So 2x minus 3x squared over 1 minus 3x quantity squared. So the second derivative is bottom times the derivative of the top, 2 minus 6x, minus the top, 2x minus 3x squared, times the derivative of the bottom, 2 times 1 minus 3x times -3, all over the square of the denominator, 1 minus 3x to the 4th power. And you can stop there because we said you don't have to simplify. Number 8, the derivative of cosine is negative sine. So negative sine tan of sine radical x. So that's the, now I differentiate tangent, which is secant squared of everything here, sine radical x, times the derivative of sine radical x, which is cosine radical x, times the derivative of radical x, which is 1/2 x to the -1/2. I can clean that up by putting the 2 and the radical x in the denominator. So negative sine tan sine radical x times secant squared sine radical x times cosine radical x over 2 radical x. Number 9, differentiate implicitly. So derivative of x squared is 2x. xy, that's a product root. First, x times derivative of the second. Derivative of y is 1 dy dx. Plus second function, y times derivative of the first with respect to x is 1. Plus y squared has a derivative of 2y dy dx. derivative of negative 5 is 0. Keep all the dy dx's on one side and factor it out. So do dy dx, x plus 2y, y goes over, 2x goes over, so negative 2x minus y, divide by x plus 2y. So dy dx is negative 2x minus y over x plus 2y, or if you want to make it look nicer with fewer negative signs, negative of 2x plus y over x plus 2y. Number 10. Okay, so it goes through the origin. Okay, this means the function's increasing for x less than 0, decreasing for x less than 0, and always concave down. So basically a parabola opening down like y equals x squared would do it. So increasing, decreasing, concave down. So that would be an answer. 11. So factor out an x, and my zeros are 0, 0, and plus or minus radical 3, 0. There are no asymptotes. First derivative is 3x squared minus 3. Factor into 3 times x squared minus 1, or 3 times x plus 1, x minus 1. So if I set f prime of x equal to 0, x is plus or minus 1. So if I plug in 1, I get negative 2, and if I plug in negative 1, I get 2. Second derivative is 6x, set that equal to 0, x is 0, so I have the origin 0, 0. Okay, so f prime of x is this, zeros at negative 1 and 1. If I plug in negative 2, I get 3 times a negative, so it's positive. Plug in a number like 0, positive, positive, negative, so the whole thing's negative. Plug in 5, positive, positive, positive. So plus minus plus, I'm doing the first derivative, so increasing, decreasing, increasing. So f is increasing from negative infinity to negative 1, union 1 to infinity. F is decreasing from negative 1 to 1. That means negative 1, 2 is a max, 1, negative 2 is a min. Set f double prime equal to 0, that was easy, x equals 0 or 0, 0. Here's a sign chart for the second derivative, 6x. If I plug in a negative, I get a negative. If I plug in a positive, I get a positive. So CD, CU. So the function is concave down from negative infinity to 0, concave up from 0 to infinity. That means 0, 0 is an inflection point. So here's the graph, increasing, decreasing, increasing. Intercepts are negative radical 3, 0, 0, 0, and radical 3, 0. Inflection point of the origin, a maximum at negative 1, 2, and a minimum at 1, negative 2. Number 12, 0, 0, y equals 2x minus 5. So x comma y, but y is 2x minus 5, I should say 2x minus 5. Okay, so the distance formula, the square of the distance from the origin is x squared plus 2x minus 5 squared minus 0. So that's x squared plus 4x squared minus 20x plus 25. So the function of x, the square of the distance, is 5x squared minus 20x plus 25. I'm going to minimize that. So f prime is 10x minus 20. Set that equal to 0. I get x equals 2. But you have to prove that you have a minimum by doing the second derivative test. F double prime is equal to 2. That's greater than 0, which means concave up, which means I have a minimum at a horizontal tangent. So that proves I have a minimum. You do need this step. If I plug in 2, I get 1. So the minimum point is 2, negative 1. Okay, so for 13, upper estimate, on each subinterval, you take the larger number, which is 5.4, 8.7, 10.2, 13.5, 17.8, and 20.9. Each subinterval is 0.5. So 0.5 times the sum of what I just said, 5.4, 8.7, 10.2, 13.5, 17.8, 20.9. That comes out to be 38.25 feet. And a lower estimate is I take the smaller number from each pair, 0, 5.4, 8.7, 10.2, 13.5, and 17.8. Add them all up, multiply by 0.5. Lower estimate is 27.8. 14, delta x is 1/4. I'm doing this in fractions. Okay, so 1/4, 1/2, 3/4, and 1. They told us to pick midpoint, so the midpoints are 1/8, 3/8, 5/8, 7/8. So the integral from 0 to 1 of x squared dx is approximately 1/4. The function values at the midpoints, f of 1/8, f of 3/8, f of 5/8, f of 7/8. We're doing x squared, it's a scoring function, so 1/4, 1/64, 9/64, 25/64, 49/64. Those are the function values at the midpoints. 84 over 256 or 21 over 64. If you did it as a decimal, that's fine, 0.38125. And finally, 15, integrate this. So 9x cubed over 3 minus 4x squared over 2 plus 5x from negative 2 to 3. comes out to be 3x cubed minus 2x squared plus 5x from -2 to 3. Plug in 3. 3 times 3 cubed is 81, minus 2 times 9 is 18, plus 5 times 3 is 15, minus, plug in -2. 3 times -8 is -24. -2 times +4 is -8. 5 times -2 is -10. Since these are all negatives and I have to distribute, I'll just make all these positive. So 81 minus 18 plus 15 plus 24 plus 8 plus 10, punch it in the machine, you get 120. All right, so this was the final exam of Calc 1, and we're done for the course. So hope you enjoyed the course, and everybody have a nice summer. Okay, thank you.